record, even though a few more people will probably pop in here. Share screen going. How's everyone's semester starting? Same as usual?
So far.
Same shit, another year?
More or less, yes.
I hear ya. All right, let's see. The last 2 weeks, I mean, the first week was mostly introductions, though I peppered in all sorts of information about the OPIS sequence. The second week was primarily resources, and we didn't get to lab 1, but that's typical looking back to the record. I never actually got to lab 1 week 1 until the third week, so here we are. So that's the goal today, to get through the first half of lab 1. But let's check on a few things here first. So making sure I actually hit record. I know I said it. Yeah, I am recording. Good. Okay. That's always number 1 on my checklist. Number 2 is the contact spreadsheet. So I have that up here. Zoom used to draw a green box around the window you're sharing, and it doesn't anymore. I am sharing this window, right? Okay. Let's see. So I think I took care of this part last time. Anyone who did not have a Skynet account has received a Skynet account now. And then for those of you who are not teaching OPIS this semester, if you are teaching OPIS this semester, I hopefully have already set up a section for you in WebAssign and sorted out your instructor username and institution code, which is not always, borderline seldom, what you'd expect it to be. Like you sign up with an email and you think that the thing before the at would be your username and the name of your institution after the at would be the institution code. And sometimes it's that easy, but usually it's not. And if you're at UNC, there's a list, but if you're not at UNC, I have to guess. The system was never really designed for how I set these things up. So I just wanted to check in because I just tried a bunch of these. Jay, I finally got you sorted out. Like I was unable to guess, you're at SDCCD, but your institution code is Miramar. So I couldn't guess that, but I saw that here and in the email. And so you're now added as of a few minutes ago to one of my sections. These other ones I tried and couldn't get to work. Art's not here. Boss, not here. Mohammed, I think he's been added to his section, so because he is offering it.
Yeah, I'm adding my section.
Oh, you are here. Yeah, there you are. So you are added. Yep. Okay. And so I got that one sorted out. Let me write added here.
And by the way, I noticed something because my actual email doesn't have a TA before it, but this one was added for my login credentials.
Yep. They do that for the instructor accounts if you're a student. They're trying to make sure grad students are less of a concern, but undergrads, you can imagine, apply for an instructor account. And so they actually do some research and try to confirm that you are who you say you are, and that if you're faculty, you just get the account. If you're a TA, they put the TA moniker in front.
Okay, I see, but there is something else. I noticed that I have limited access, unlike an instructor. So whenever I need to modify something, I need to bother the professor responsible for my class.
Take care of that right now.
Okay.
It's just the one section, I believe.
Yes.
I might need to reboot my computer, not now during our meeting, but some of these web pages have gotten quite slow, and I'm beginning to suspect because I haven't rebooted my machine for a long time. This is borderline ridiculous. Come on. Here we go. Here you are. Oh yeah. I don't think I added you because I would not have given you that set of permissions.
I'm not
Maybe
sure.
Evan added you.
I think Evan sent an email to the technical support and they did add me.
Okay. They must have set those permissions. So now, as soon as this processes, you will have updated permissions. Okay. You're good to go.
Thank you.
Brad, I just
Yes.
tried yours and it did not work. So I just wanted to confirm before I emailed them, you have applied for a user account, an instructor account?
I mean, oh, wait a minute. I'm signed in now
Oh, are you?
using that name,
Okay.
signed in under that username and password. Unless this is somehow a student account.
Could be. Maybe it needs to be upgraded to an instructor account.
Well, wait, there's a view as student button here.
You're an instructor, so so you have an account. It must just be a setting I couldn't guess.
Okay.
Like Jay here, it had an institution code that I never would have been able to guess from the email. So I will make a note that I need to email.
Okay. Yeah, I can't find any other account settings in here. When I try to view my account, it just takes me back to the login page. So I can't find an institution code or anything.
They don't tell you what that is. It's just something that's internal. And yeah, anyway, I'll
Okay.
work on that. And now a boss is here. And have you had any luck? You were going to sign up under UNC as the institution, if I remember.
Yes, thank you. Just a little bit late. Sorry. I tried to do I'm not sure about the account for the student or instructor, but I try both of them, but both of them they say pending. I'm not sure which one I should follow.
I'll email Cengage with both of these same time. And let's see, is that everyone? Everyone who's here anyway. Okay. And I'll ask about art.
Thank you.
Yeah, I'll make a note here to just email that one anyway. Try to get these sorted out. Okay. All right, let's see what's next. Last week's video has been posted, the usual place. I think I'll put the link in the chat one last time. I won't do this every week, but this is where the videos are being recorded. For those of you who may not have been here last week or previous week, you can find them there. Or again, a complete set from the year before here, because we started a week late. I don't know how that happened. Sometimes each year gets harder and harder to drag yourself from summer into the new semester. And so we're a week later than the previous year. And so if we get behind, you can consult those. Art is here, so I just want to check. Art, any word from Cengage on your account? On your instructor account? I don't know if you can hear me. You're mute. Yeah, there you are. Hey, Art.
Yeah, no, I haven't heard anything.
Okay, but you did email them, and I did try it this morning. So, okay, and we just had a conversation about this. There are a couple of them that didn't go through. Sorry, something in my throat. And I'll email them after this meeting, trying to get those moved along.
All right.
Because now with the training, we're going to be moving into the labs, and you're really going to want to access the labs. Okay. So last week's video, previous videos. Okay, WebAssign. Let me just log out again. I think I showed the login aspect last time. I'll just start from the beginning. So WebAssign, I'll just start with webassign.net. Your students go here. If you have a section created, it has a class key. I've distributed that. So the student clicks on enter class key. They type in the class key. It associates them with the course I set up for you and have made you an instructor in, and then they finish their account setup. Okay. Or you can go to sign in, which takes you to webassign.net /login, which redirects here. Yeah, webassign.net /login.html redirects you to this page by Cengage, because Cengage bought WebAssign a couple years ago, and you log in with whatever email you signed up with. I signed up with my Gmail. Password. And mine takes a moment to load, either because, as I was saying, I haven't rebooted my computer for a long time, so everything seems slow right now. Or just in my case, since I set up the sections for everyone, there are a lot of sections, and it takes a moment. It's almost here. Okay. I'll go to one of my sections. Okay, so I have all the labs here, including both 2S and 2G. As I create sections for other people, I'm just basically copying this section. Once my students get into lab 2, I'm going to turn off 2S because I'm using the Globe version of lab 2. But anyway, I don't think I mentioned this before, but once I set up your section for you, you go here to reschedule assignments. There we go. You can turn labs on and off, like I'm not going to want 2S. I'm using 2G, so I can turn it off. You can change when they're available. I just have everything available on the first day of class. Sometimes when you copy from previous years, some of it doesn't come out right. And I like to have everything available from the get-go instead of a staggered release. I used to do a staggered release, but they do have to put in observations well ahead of time, as we'll talk about. And so it's useful for them to be able to see the lab, future labs in advance. So I just have them all there. The due dates, you'll want to modify those to your own schedule. Again, not everyone uses every lab, so you can turn off a whole bunch of these if you want. And view until, I usually have this the last day of the semester. Okay. Made a few little changes there, so I'm going to save them. But when you first get your account, this is where you go to modify everything. As soon as it moves me back to the main page. Okay. I'm going to open up to view a lab. You go here to view. There are other things under edit. You probably don't need to go there. This is if you want to change the parameters of how it's set up. Like if you want them to be able to view answers upon submission or after the due date. By default, I have it set up that no one sees anything until after the due date and time. So one student can't get the answers and give it to others. Most people just go with my default setup, but you have other options here if you want. Schedule is just another way to do the stuff that I showed you here. Then scores, as students are working on labs, you can see the scores on each of their questions there. Well, maybe I'll go here just for a second. My students are just starting lab 1 next week. So here I have one student who's already done it, even though lab 1 hasn't met yet. There's a future astronomer, got a lot of points too. I'll have to check that out. But anyway, you can see the number of points. Lab 1 is broken up into 2 sections, week 1 and week 2. There are no points with week 1. You'll see that as I show you lab 1. But anyway, you can see their scores here. You can click on their names and see their, their individual, what they submitted. And they're also, you can, select any of these that you want. Go here and grant extensions. Let's go to one of these. I wasn't planning on doing this stuff right now, but why not? And so you go in and you can see their individual submissions. For part 1 of Lab 1, it's all about submitting the observations. That's what we're going to do today. Down here in part 2, you can see the stuff they submitted. I'm absolutely shocked that students completed the lab before we've even met. Yeah, Mars isn't very pretty right now. I'm just curious. The student actually doing it all. Let's see how their Saturn image turned out. Yeah, okay. And you know, there are questions and things and measurements. And anyway, at the top here, there's this valuable thing. A couple things here. One is log info. Student tells you, oh, I couldn't get it done because whatever bogus excuse they make up. You can go to the log and it shows you everything they did. Every time they access the site, it says download. It has the IP that they accessed it from and when. Every time they saved or submitted anything, it's here. So you have a complete log. So, you know, often students will make up some lie. They don't know about this, and I can go and check. And it's like, oh, they opened it up 4 minutes before the due time. No sympathy, you know. And so that's nice. And one last bit here before we get into the content. Save submitted work. Often, so yeah, I was going to mention this at some point. I got my notes here. WebAssign has both save buttons and submit buttons. But I've set it up that they can just use the submit button. If they save and forget to submit, then you don't see it when you get into that grading mode. Unless you you'll see something up here saying submit save work. This one's not highlighted because this student actually submitted everything. But sometimes they save stuff and forget to submit, and you as the instructor can submit it here when you're grading. Anyway, those are just a few basic things. Let's go back to the main site here. And feel free to interrupt at any point with questions. Okay, I'm going actually to not the main site, but this particular section. And you can see I've added some of you as additional graders. This one here is my default TA. Instead of I have new TAs every semester. I have a bunch of them, so I just have one account. They share it. Okay, so today we're doing Lab 1. Now, you can view it as a student if you want to see what the student sees. It's a little bit nicer presentation, but it's about the same. We're just going to do the instructor view here. I actually already had it open, but delete one of these. Okay, and yeah, here we go. Okay, so we have the stuff at the top. I think I started to explain some of the stuff at the top here. At the very top, we have a set of overview videos. There are 2 sets of videos that I've shot for this, the overview videos and the how-to videos. The how-to videos are embedded in the procedure. The students will use those aggressively. A lot of the how-to aspects, you know, how to submit an observation, how to measure something in an image, etc. We don't write out all the instructions because the interfaces keep changing. We keep improving and modifying the interfaces. So I found it's better to simply have a video, and then I have a few notes after the video. Anyway, those are the how-to videos. They're embedded farther down. These are the overview videos. And looking at the YouTube logs, the students don't use these as much. You know, a lot of students come to lab, they haven't read anything. They come unprepared. For my labs, I have my TAs do a 5-question quiz, beginning of lab. Easy stuff if they at least skimmed the lab. Anyway, we have these overview videos for the students. And students can use them. Students don't like to read anymore. They're used to watching videos, so we did this. But they're also there for you as instructors. This is all stuff you're going to have to explain to your students. It's similar to what we're going through today. And so if you're a first-time instructor and you don't know what to do or what to present, you can watch these videos and it gives you a good idea. The first video is always, well, you click on the videos and almost every video will come to this page, and there's usually 2 buttons. I think I explained this last time, original and enhanced. Glass education, there are blind, visually impaired, deaf, hard of hearing, accessibility experts. And they took my original videos and zoomed in, made the stuff I'm talking about larger, zoomed in on my head, made it bigger so people who are hard of hearing can see my lips move more easily. They cleaned up all the closed captioning so it doesn't say silly stuff. They added arrows and diagrammic stuff on top of the video. So there's the enhanced. For these overview videos, there's nothing extra. And so introduction video. The introduction video's like 2-minute introduction, nothing fancy or special. Instructions here, I go over what's at the top. This is only in lab 1. I'm going to go over this stuff right now. So the stuff in this video is what I'm going to talk about. What do we have? In addition to the overview videos, we have notes. And this note is unique to lab 1. In lab 1, they're going to be, it's not very scientifically deep, lab 1. This is more about getting used to the system, developing a toolkit, how to place observations, how to manipulate images and measure things in them. That's week 1 and week 2. And so we're going to take a lot of images, and mostly solar system images because they're bright targets for the most part. So short exposure times, you don't burn through a lot of credits. So they can ramp up without breaking the bank. Though we do have a few deep sky objects, dwarf planets, things that take longer exposures. But half of them will not be observable. And forgive me if I went through this part last time. I do recall that I wanted to go through this and ran out of time, but it all blurs together. In case I didn't, of course, half the targets, we have all the solar system targets, deep sky, et cetera, et cetera. Half of them won't be observable because the sun's in the sky. You all understand this. They don't, and they get a little panicky because in lab 1, it's worth, I think it says up here somewhere, maybe it's on their view. I think this one's 134 points. They will not get all 134 points. They may get 80 or 90, depending on, at most, if they do everything right, depending on what targets are available right now. And often they'll put their targets in, and there's some they can't. They come back the next day, and it's still not observable. They come back the next day, it's still not observable. Yeah, the sun moves around the sky once a year. The changes are seasonal and slow. If Venus is not observable today, it's probably not observable tomorrow. So you want to get that across to them. They're not going to be able to hit all the targets. If the lab does go on 1 or 2 weeks, there may be a target that you can get early on that you lose. There may be another target that's almost observable, and now it becomes observable. There are a few games you can play when submitting the observation to like reach farther down on the horizon or not, bright on the brighter side of twilight to try to pull some extra stuff out. I'll mention those tricks. But so when they get 80 out of 130, they're panicked because they think they just failed. They got like half the points or something. And so you just got to convey to them that you can't get all the points here. It's going to be okay. I will set the grading scale appropriately. And that's up to you how to do it. I use curves because I have multiple TAs, and even though I have a grading guide, they all grade differently. Some are lean, some are softies, and some are trying to I don't know, exercise their power. And no one's grade should be based upon what TA they randomly got. So I have to use curves. Anyway, in later labs, the notes change. Here's lab 2. And here, like the note is sometimes, usually there aren't questions in the background sections, but if there are, I put a little note here because often students will just outright skip the background sections and go straight to the procedure and hope for the best. And so this is just a little reminder, hey, there are some points to be had in the background. And then there's always this one after lab 1. to go back and review your sources of error. 1 second after the labs close, they can hit a button at the top, and it warns them, if you hit this button, you're going to see the answer key, and your instructor will know that you have seen the answer key. That's in score view. They put a little symbol there. So, if they come back asking for you to reopen it for them, you'll know if they've seen the answers or not. But anyway, they can go there and review what they got wrong. Often students don't, but for sources of error, I really, really encourage this, because students are terrible, terrible, terrible at explaining sources of error. They like to write human error, but if it's a human error, that means you can just go back and fix it. Or calculational error, go back and recalculate it. You know the drill with sources of error. There are things that we look for sources of error. This uncertainty is due to a fundamental limitation in my measuring device, that kind of stuff. And they're really bad at, and they'll only improve if they look at the answers. So that's always there as a reminder as well. Okay, continuing. Then we have the observation guide. And did I talk about the observation guide last time? I did. Okay. Yep. So I don't have to go through it again, but it's there at the top of every lab. And again, in your orientation section, you probably want to pull this up and fill it out so they know how early they have to submit their observations for them to go through. And there are also extra, in the guide there, if you go past that table for each lab, it tells you, here's the link to the section. You're working on lab 2, but you got to put in your observations for lab 3. It says, okay, this is the exact section you want to go to in lab 3. So you don't have to search the whole lab for it. And also here's the video that goes with it on how to submit the observation. So it's all there in the observer guide. There are a few extra hints to help them along. And then these final reminders. And yeah, my recollection is I didn't get to this last time. Here's the bit about save versus submit. A couple years ago, they added both buttons, but I've set it up just so they can forget the save button, just always use submit. It gives them 100 submissions per question, and if they don't change a question, it doesn't count against them. So for each individual box, they could change their mind 100 times and it would be okay. So just use the submit button, and then you run into fewer of these cases where they save but forgot to submit, and maybe you grade the wrong thing because of that. Here's an important thing. WebAssign doesn't confirm. They submit and no box appears saying, got it. We have received your submission. It just goes back to the page. And this kind of freaks out the students. These labs are projects, and they complete a big project, they submit, and nothing. And I think it's because WebAssign's mostly set up that once you submit, it shows you the answers. But I have it set up that it won't show the answers until after the due date and time, so people don't share answers. And also people are using the submit as a save, so there's no fanfare. And you'll get some questions about this on the first lab, but after that, they'll stop asking. They'll get it. If they want to make sure, and it tells them right here, you should log out, log back in, make sure WebAssign has your answers. That's on you. So they can't come to you and say, I submitted, I swear. And that's when you go to log and see they never even logged on, right? Okay. Enter all calculated values with at least 3 significant digits, unless otherwise specified. A lot of this is auto-graded, which is great. You'll still have to grade the short answers and the images and graphs and things, but all the calculational stuff is auto-graded, so that saves you effort. But if they don't put enough significant digits, it could be marked wrong.
Hey Dan, quick question.
Yeah.
Do you make the students aware that you have the log ahead of time?
I don't.
You wait for them to come to you and
I don't, but it's out of negligence. So I'm not teaching it. I have TAs. I teach them like I'm training you, and they go in, and this is for them their first teaching experience, and I just forget to tell them until an issue arises, and then I'm like, oh, let's go check the log. And so, but yeah, I probably wouldn't tell them anyway.
Wait for them to find out the hard way, right?
The hard way, yeah.
No forewarning. Okay.
Yeah. Though on that note, I am pretty lenient once I catch them. The first time, I'll just give them 0 for that question. The second time, I give them 0 for the lab. And only after that do I report them to honor court, even though I'm supposed to report them immediately. I've never actually reported anyone to honor court. If I catch people cheating, I bring them in, I make them cry. I've had like big burly football players weeping tears, and that's their punishment. At UNC, I do let them know that if they are, 99% of cases that go to honor court, you're found guilty, and they put it right on your transcript. Basically, you are a liar and a cheat, and it stays there 10 years. And so I do tell my students that, and scare them that way. All right. And also I think I may have mentioned, as they submit images and graphs, yeah, I did mention this, we imprint their name, who did the work, into the EXIF data on the JPEG. And you upload an EXIF viewer. We'll talk about this on grading day. And whenever you're imaging or grading an image or a graph, you right click and you can see who actually did it or if someone shared it. What else? Scientific notation, it has to be in this form, can't be like this. And it's my plan to move this instruction, to keep it there, but also put it everywhere in the lab when they have to submit scientific notation. I don't think it's anywhere in this lab, but they forget. This is interpreted as a string, and it just comes back blank. Like, I swear I answered something here, but, it just erases it. It's like, I'm expecting a number, not a word. And so they got to get scientific notation correct. Don't add units, because then it becomes a word. The units I write outside the box. And when naming files, it's best to avoid special characters. Okay. Content. I'm going to close up for whatever reason. I think I was looking at this stuff ahead of time. Let me just close everything down here. Okay, there's the end. No, I should have done from the top. How inefficiently can I do this? Let's see. Okay. So when it comes up, the first accordion tab is open, but the rest are closed. I do like this accordion format, so it's easier to find things instead of just one long scrolling web page. This first lab, there's too much material for them to put in a single question. So they broke it up into 2 parts. We would call it parts. They call it, WebAssign calls it questions. Though within each of these tabs, there are lots of questions, boxes that students will have to put stuff in, but it's broken into 2 questions. And this one works out nicely because there's a week 1 and week 2. Okay, so the first bit here in each lab is the goals. These are the goals for both weeks. Here's the goal for the first week. They're going to learn how to use our system, how to submit observations to prompt telescopes in Chile, Australia, and Canada, and to the broader network of Skynet telescopes. The prompt telescopes are the ones that we built and maintain, the UNC did, and they are generally higher quality, and we have them, all over the place. Though, like right now, I have a whole bunch of them down due to the conflicts of terrible maintenance issues. So we probably have 3 or 4 at the moment. And as you get closer to due dates for students who didn't actually submit in advance and they're getting desperate, we tell them then go ahead and put things on all the Skynet telescopes. But the prompt telescopes tend to be higher quality. There are also high quality ones that are not prompt, but it's a greater likelihood of high quality if they use prompt telescopes. Other goals. This basic stuff, and this is in week 2. Once they get their images back, how do you change brightness and contrast to better view detail? The CCDs anyway are 16-bit. The CMOS is 14-bit, if I recall. But still, that's more information than the human brain can visualize at once. So you can either look at the bright detail and not see the faint stuff, or the faint detail and saturate the bright stuff. And so we teach them how to adjust that so they can see what they want to see. We teach them how to measure angles in their images, sizes of objects, distances between objects. And we teach them how to identify objects in their images that are moving, such as moons going around a planet or dwarf planets going around the sun. How do you figure out which of these points is which? So these three we'll talk about next week. In this first week, there are no questions for them to answer, actually. All the work is presented in the second week. This is just background and submitting their first set of observations. Equipment, in this lab, it's just an internet connection. Then we have some background sections. I'll go through these now. And again, this stuff is covered here in the background video. Okay, prompt telescopes. So as I mentioned, the key telescopes, the best telescopes, generally speaking, are the prompt telescopes. Here's a little section. These are very brief. All these sections are very brief because I know they don't have great attention span. Here's a fun video. I may have showed it last time as we're talking about supplemental materials. Yeah, how to build 6 telescopes in 60 seconds. I think I showed some of these pictures last time. This is actually what it looks like when you're there. It's amazing. You can't even see constellations. There's so many stars. And I mentioned, and that's Chile. That's our best site. That's where we have most prompt telescopes. These are all prompt telescopes. And then we also have sites in Australia. Currently only 1 telescope open, but it will be 5 in time. And 2 prompt telescopes up in Canada, one of which will be moved to Arizona. Here's our Australia site at Siding Spring Observatory, though one of these I've already moved out of the dome and over to the other side of Australia, Perth, just for better protection against weather coverage. Here's a little video of the dome's opening. I think I showed this last time as well, so I won't go into that. And here you can view which, that's strange. It's only linking, okay, yeah, this is just a link to the CTO ones. I don't know why. Well, not all telescopes have webcams. We do have a webcam that watches the whole site. It's clearly down at the moment, but you can go to any individual telescope as well. And this is a live view of the telescope. Even at night, once the dome is open, if the moon is out, you can still see the telescope and watch it move around. And actually, during our orientation week, which is for us next week, we bring the students over to the observatory from their classroom, and we have our Moorhead telescope up on the roof, and they learn how to put observations in and watch it move. And I find that's a really useful experience to actually see that these telescopes are real anyway. So if anyone ever wants to do something like that, we can coordinate, and even if it's not in person, remote, or we can set you up and show you how to remote access. The other thing we do is we take them into our remote ops room, which is right over there, and we remote desktop into these things, or Rust desk into them, and just take them off Skynet and move them around, open, close the dome, and turn the lights on and off from the other side of the world, and they find that pretty cool. Okay, let's go back. Close that. Okay, a little bit about the history of prompt, why we ended up building the site. And prompt was originally just the site in Chile before there's a Skynet wrapped around it, and they were going after gamma ray bursts. We built the site in 2004. So I was a grad student in 2000. I graduated in 2000. My advisor and I wrote a paper saying you'll be able to see these things farther out than any other explosive processes and use them as backlights to study the early universe. And so then I said, okay, I'm gonna switch over from theory to instrumentation, actually build the machines to go find these things. The trick was you have to be quick because they fade very quickly. And the reason prompt is a handful of small telescopes is it was originally built to be a photo-Z machine. Basically, these gamma ray burst afterglows, they emit across the full spectrum, but in the source frame ultraviolet, that light's all gobbled up. And then it gets cosmologically redshifted into the optical band. So originally, each telescope did a different filter. Right now, we have like every filter on every telescope because it's more for education and broad-based science now. But the farther away it is, you won't see it in the blue optical. And we started building this thing in December of 2004, and by September of 2005, we found something in the infrared using the SOAR telescope, UNC's 4-meter, one mountain away. And that alone is not anything unusual. Gamma ray bursts have afterglows. But we looked in the optical here, and given how bright it was, even though these telescopes are smaller, it should have been able to see it, and it didn't. That very significantly, that indicated it was very high redshift, redshift 6.3, broke the record. That's it's written here, 12.9 billion light years away. The universe is only 13.8. So we've broken the first billion years of history. Anyway, the reason I have this here is not to like brag or anything, but to let them know that, and this is important, and the education research shows this is important, they're not using toy telescopes or your campus, like a 3.5 inch that you may have for nighttime activities. These are professional telescopes making cutting edge discoveries. We've published in Nature or Science a total of 5 times. We're the first to find rings around solar system bodies other than the gas giants. We've seen planets colliding, making giant debris clouds blocking their stars, etc. So it's being used, the same telescopes, the same interface to do cutting edge science. Skynet will observe something for a pro and then says, okay, I'll do this one for a student. Maybe this student here, now back over here for this pro. They're using cutting edge instrumentation. It's a real treat and privilege. And so I try to convey that to them. It increases the excitement level. Continuing on. Okay, how a telescope works. We talked about this a lot last time. The older versions of these labs were, okay, come out at night. We're going to look through these 3.5 inch telescopes and do stuff that doesn't really connect with what's in lecture because they're not that capable. And most of the time, you're going to be fighting with the equipment. Now they're fancy go-to telescopes, but back then it was just a real pain to use them. And that's why we came up with Skynet. We made this decision that we're not going to teach them how to fight with telescopes. That's for the majors. We want to get straight to the science. That said, they should understand a little about how a telescope works. So you may want to bring one of those 3.5 inch telescopes into class, into lab, and explain like the optical train. Here's a picture of me next to one to make it look cool. No, that's just my standard joke. It's to show the size. This is one of our smaller telescopes, 16 inch. We get up to 32 inch, twice the diameter. And then the optical path, it comes in, bounces off the primary, bounces off the secondary, goes down through what's called a light baffle, just a tube to block stray light as much as possible, through a hole in the primary. And we weren't using the middle anyway because it's blocked by the secondary. And it goes straight through a filter wheel and a digital camera. And this one, it's open aperture. Most telescopes are wrapped in a tube. But since these are in domes that open up at the beginning of the night, the wind is always hitting the telescope. It's not like you're in a closed dome and it's protected. And so we got rid of the tube because it was a wind sail. And the wind catches it and pushes on the telescope, blurring your image. So these are open aperture, so the wind goes through. We can observe up to about 20, 25 miles per hour without much distortion. This is called a Cassegrain system. When it folds this way and goes through the primary, it's a Cassegrain. But what are some of the points to make? The most important part of the telescope is the mount. Because remember, it's sitting on a rotating planet. If you want to observe the sky, this has to rotate the exact same rate as the planet in the opposite direction. If it doesn't do it smoothly, you're going to have distorted images. And it also, your field of view is tiny. For a lot of these, it's 1/6 of a degree. It's like this little hole between my fingers at arm's length. So I need to be able to point the thing really well. So the mount's critical, and we've replaced all these mounts. These are pair mounts. They weren't the greatest. We now use plane wave. But the cool thing to talk about is the filter wheel camera. Their phones have what? What's it up to now? 8, 9, 10, 12 megapixels? I don't know, something like that. A lot of these Skynet systems are still on 1 megapixel. And and they're black and white. They're not even color yet. A black and white 1 megapixel would cost 15,000. It's actually more now because you can't get CCDs anymore because the market switched over to CMOSs and they're always larger format. So why would a camera with fewer pixels, black and white only, cost so much money? It's a couple reasons. And why would we want them? Well, one, they can see in the dark. They're cooled down to really reduce the noise level. They can see in the dark. I often tell my students, you could test this with your cell phone camera. I assign as homework, lock yourself in a dark closet and take a selfie. And when they don't see anything, it's because their phone doesn't see in low light levels. But our cameras do, and that costs extra money. Also, why do we have black and white? Well, we do make color pictures, but we use filter wheels, different colors of glass, and sometimes they're special for picking out certain elements and whatnot, but here's a standard red, green, blue. And in their phone cameras, if you zoom in, you have a Bayer array where it's like red, green, green, blue, or red, green, blue, blue. I forget what the Bayer is. But often our stars are matched to our pixel size, and a star may only be covered by a few pixels. And let's say it's the red pixel, and astronomers are going to want to know how much green light was under that pixel, and we can't do that. In their cameras, it's all just kind of blurred together. So we take one image using all the pixels in red, then switch the filter, all in green, all in blue. You know this stuff. I'm just presenting it as you might to your students. And we combine them after the fact into a color image. We don't do too much of this in OPIS. OPIS, as I described before, is usually single shot black and white stuff, so it can scale to national levels. But there is a little extra activity here and beyond the labs, or maybe it's lower down, I can't remember, where they pick one of their favorite deep sky objects once they come back and shoot it red, green, blue, and learn how to make a color picture. It's an extra credit activity. And I normally actually do it with them later on when there's more of a break in the schedule, but they take the images here. Almost done with the background. Maintenance, we just tell them, remind them that these telescopes break. Many things Skynet auto detects and fixes it itself just by cycling power, etc. Some things it breaks and Skynet will send us alerts saying, hey, I can't fix this, you should take a look at it. And we log on and we have it fixed within minutes or hours, that kind of thing. Sometimes it's something we can't fix remotely and we have to call up staff, on-site observatory staff. That would take a day or so. And sometimes something's broken and we have to send it back to the vendor and the scope can be down for months. So that's why when they submit their observations, they almost always want to use many telescopes, like all the prompt telescopes available to them, or if they're really desperate, all the telescopes available to them, because some will go down for maintenance or weather or whatnot. And lastly, an introduction to the larger network. They can explore telescope sites here. They can go to any particular site and learn about it. And also what telescopes are currently connected under Skynet Live. That's here. Yeah, I showed you the sites when we were looking at the webcams. Like here's this Ceratololo site. It shows you what telescopes are there, recent images. Again, you can pop into a recent telescope and see what it's up to, what filters it has on it, the size of its chip, etc. And Skynet Live here is what's currently connected. So this one's in Poland, and it's observing a gamma ray burst that went off about a couple hours ago. Yeah, Astrodil, he's my grad student. A lot of them have bad weather right now. Almost all of them, the sun is up, except this one here's in Australia. This one's in Poland. And this Australia one, the weather's bad, so it's closed right now. Anyway, those are the background sections. The procedure, once I show you how to submit an observation, the rest is just the same thing repeated many times. So I think I can still do this in the 11 minutes we have. So how to observe with Skynet. This link takes you to the Skynet site. Here's a how-to video on how to do this. And then there are a few reminders after the fact. But instead of going through these here, let's just go to the Skynet site. And I go to the home page first. So we have these different regions. We've already explored telescope sites and Skynet Live. So under my observatory, the students will see optical observing, radio observing, and my account. My account is like password management, etc. You will, if you're running a section, you as the instructor will also see group management. And this is where you can add students to your group, transfer credits, etc. Let's go into optical observing. For whatever reason, this has been slow to load for me. Again, I might just need to reboot my laptop, though could be something on the Skynet site slowing it down. That wasn't too bad. And so this would be a list of all of their or your observations, which ones are active. I put these in this morning, just going through the stuff I'm about to show you. Completed observations, recent observations. Here's a 0.03 second of image of Polaris. I'm getting ready for that nova that's going to explode. And it's supposed to get as bright as Polaris, so I'm doing some tests for exposure lanes. Anyway, let's add a new observation. And there are a couple ways you can do this. There's like a keyword lookup. I know tarantula is a good one. It's a good Southern Hemisphere nebula. It brings up a DSS image. Here you can see it's a circumpolar one, so it's always up all season. So it's one of my go-to ones. So they can search things by looking them up here. We also have the sky viewer. So here's now. It's currently set for Meckering, but I can set it for other observatories. Like Tololo, right now, the sun is still up. I'll go back to Meckering. That's our prompt telescope in Australia. So right now it's nighttime and tarantula is up. I can image it. I can look forward and backwards in time. I can zoom in to certain regions. Now maybe I want M78 instead, a reflection, famous reflection nebula. Anyway, so you can select things that way. You can zoom out using the buttons or draw a backwards box and you zoom out. And if you have any BVI students, you can go to a tabular version of this that works with screen readers if they can't navigate this visually. And you can turn different things on and off. And you can change the rate at which things advance, whatnot. Anyway, once you select your object, it fills in the R in the deck. If it's a moving object, it will update these right before dispatch. You can change the name, whatever you want, maybe even spell correctly. And here are the default settings we encourage the OPIS users to use. Professionals wait until the sun is 18 degrees below. I recommend -12. The students are looking at big, bright targets. So this way they get in before the professionals start to dominate the telescopes. It's still, the sky is dark enough. Professionals usually wait until something's 30 degrees above the horizon. We tell the students 20 is fine. And min visible hours, it's not up for at least half an hour. Odds that it'll carry it out for, them during that half hour instead of doing other things, it gets pretty slim. So if it's less than half an hour, we don't even really try it. Max moon phase, in OPIS, we'll observe under all lunar conditions. The moon can be full. Normally, we tell the students to stay about 30 degrees away from the moon, unless you're looking at the moon, or like Jupiter, Saturn, Venus, that'd be fine too. So normally set to 30. I'll just leave it at 0 because we'll look at the moon in a second. Advanced settings, that's like pointing offsets. If you're looking at something like an asteroid with orbital elements, dithering, they don't need any of that. Then you have an air mass chart down here. And it shows for all the different observatories. And Skynet 2, this is way, way better. And actually we've actually coded in about half of Stellarium into the Skynet 2 interface. It's so sweet. This is so primitive compared to what's going to be available in a year. But we have a lot of Northern Hemisphere facilities. We find prompt, that's Tololo. If you click on it, you can make it blink and figure out which one. So if I want this at Tololo, it's going to be up in 11 hours. Anyway, let's do Saturn. Because in Lab 1, we do a lot of planets. There's Saturn. I know it's observable right now. Yep, very observable. So the next thing they do is they pick their filters. not the telescopes. Sometimes there are reasons to do telescope first, but in this lab sequence, filter first. There are lots of options, and labs tell you what. For Saturn, it's in the lab. You'll see it. It recommends B-band exposures, 0.3 seconds in B-band to look at Saturn. So I select B and C. I lost some telescopes. Some telescopes didn't have a B filter. Most of them do. Some observations, we use a U filter. If it's really bright, U blocks a lot of light. The atmosphere blocks a lot of light in U, so I use it as a low throughput. And fewer telescopes have that. But they'll be using U, they'll be using B. If I select both, it's like an and. If I do that and like an obscure one like S2, very few telescopes actually have that weird combination. Put it back to B. That's an and. For an or, these are ors like high through. I'll take anything, open, clear, lume. Or a low through, I'll take any narrow band or a U band. All of them block most of the light. And there are different cases when, like if you're looking at the moon, any low through filter is fine. Anyway, for this thing of Saturn, B is all you need. Save and continue. And so here's a list of all the telescopes, and some of them may be closed that have that filter and that can reach that target. It's at a latitude that it can observe. And they can go through, if they have plenty of time, I encourage them to find all the prompt telescopes and click on them, prompt 8. I have many time accounts. And so it has to be, if I select many, it has to correspond to a time account that has them all. Or other ones like this Polish one is really good. Or if they're getting desperate and want to use anything, they'll just have one time account. They click the orange dot and it will click everything in the time account for them. So this means whichever of these telescopes is available first, all of them have the filter I need. They're at the right latitude. Whichever's first, we'll do it. Then here we are on the second last page. And 3 minutes. I'll get through almost everything in Lab 1, Week 1. The rest we'll do next time. But let me get through submitting an observation. We are a heterogeneous system. Every telescope is different. And so what we do, most of the labs are designed around a generic telescope. This is a 16-inch telescope at Tololo. So in the lab, it says I need one exposure for 0.3 seconds. And here are all the telescopes, and you can see as I hover over each one, it changes the exposure time. Because some have higher throughput, some have lower throughput. This is something we're always measuring on the fly. And so it will adjust the exposure time to give you the same signal to noise. And telescopes that require longer exposures, the credits are worth less and you can burn more of them. In other words, it's the same number of credits to do a long exposure on a poor telescope as it is to do a short exposure on a great telescope. If you're doing something really long, like here's 200 seconds, that translates into longer than the telescope can accurately track. So it would get rid of a lot of them. Or if you're doing something too short, like 0.03 is the limit, these two telescopes would change it to less than 0.03 and the shutter can't move that quick. Anyway, so you can lose a few telescopes at this stage. It's okay. So I'm going to do one at 0.3. And these are advanced options. We don't need these now. Save and continue. And that summarizes everything you submit. Slow, it's adding it to the database. It's cranking. And then it will show up in your list. It's that easy to put in an observation. I wonder why these two screens, just when I go to the add observation or the observation page, oh, it's going back to the observation page. Something about the observation page is just creeping right now. You'll get there in a second. But you'll see it'll be in the list. It'll be listed as active. And once it's done, it's switched to complete. And once the data's been transferred, it's switched to archived. I'm going to ask my programmers about why that's slow. Let's see, what else do I have here? Well, that's coming back. I'll just mention a few things real quick, even though it's 4. I can now crank through almost all of these super quick. Can I have 3 more minutes? Okay, here we go. This one, so it tells them once your images come back, check every day, see what came back. It's probably only going to take a day or two. You don't want to just assume it's going to be good. About 20% of observations will need to be resubmitted. These are common failure modes. Like if you're covered in clouds, all you're really doing is blanket illuminating your detector. And so you can see all the defects. Like at bluer wavelengths, you can actually see the manufacturer scraping pattern of the detector. And these circles that's dust on the camera lens out of focus. So if they're looking at clouds, they'll look like that. Here's a mixture of clouds, like thin clouds. You get both. That's good. A little bit of wind causing streaking. Here the mount is misbehaving. Though with bright things like Jupiter, Saturn, Venus, we purposefully offset them from the center of the chip because bright objects will burn into your detector and leave a ghost for about 20 minutes. You can't get rid of it. Even flushing the camera can't get rid of it. Well, there are ways, but we try to protect that region for the professional users. Here's tracking stopped. It's out of focus. The shutter is the part that moves the most, so it breaks the most. And sometimes if it doesn't close completely, you'll get these kinds of streaks off your bright stars, or here it's stuck in the open position. So if you see stuff like this, we have a sticky shutter, just email me. Someone left the lights on or the moon's too close. Satellite, if 2 of them, it's an airplane. Those are the lights on the wings. In fact, assume it's a 747, and in Afterglow, measure the angular size, look up the physical size of a 747, neglect projection effects, and they can calculate the distance. It's a fun little side activity. And occasionally there's a bug in the system. 3 times we've imaged a bug actually was on the filter wheel. These last bits go super quick. So then they put in their observations and make them do it in lab. If you send them home, they may forget to do it until the day before the lab's due. So here we're going to put in the planets. So we have them here. What filter to use, what exposure time. Just a reminder, it's not going to look like what you find on the internet. That was taken by something orbiting around the planet. Theirs is going to look like this. In fact, I'm back at the observation page. Let me show you an example of Saturn. I'm at the add observation page. I will if there's time at the end. Then we have them go back and do the moons, the bright moons around the gas giant. So they target the gas giant again. Filters that let in more light with appropriate exposure times. Here's an example of Jupiter, where the brightness and contrast has been changed so you can see the moons. Dwarf planets, we do Ceres, Pluto, Haumea, Makemake. Haumea, Makemake may or may not come through. We are burning 160 seconds on these. Pluto, 80 seconds. And, it's just going to look like a field of stars. This is a Where's Waldo exercise that we'll learn how to do next time. And second to last, we say pick a nebula. Looks like WebAssign got a typo in here. One nebula, 1 star cluster, and 1 galaxy. And students love having this choice. Each of these is a link to Wikipedia. They'll poke through, they'll pick the one they like, and they get to do 1 of each. And then lastly, they get to do Earth's moon. Show that super quick. Oh, here, let me show you an example of one of these. Like here's Saturn. See, here's Saturn as imaged by prompt Meckering. So, okay, a little fuzzy. Here it is imaged at Certololo. Better, right? Tololo is just an awesome site. But again, it's going to be teeny tiny. It's not going to be like you're in orbit. And so for the moon, I've gone my 3 minutes over. Should I save the moon for next time? Or do you want to see how to do the moon now and be done with lab 1? You all now?
I'll stay because I'm doing this lab in a couple days.
Okay. Here's the last one. I'm going to put a new observation in. please load a little faster than before. Maybe if I just go hit the back page. So the moon is a little different because they're going to position the field of view on a certain part of the moon. This delay is just killing me here. And so for that, you have to pick a single telescope. Here we go. Add a new observation. It's going to be the moon. And right now we're having some problems with their telescopes in Chile. They'll come back online soon, but your best bet's probably like Meckering or something. So here's now. Let me go. Yeah, the moon is close to the sun right now, but within a few days, you have a better separation. I'll zoom in here. Oops, that's the now button. I meant the pause button. I get the sun out of the sky. Try zooming in again. Got the phase in there, and it'll be moving, so you can hit the pause button. You can position, you pick whatever observatory you're going to use, whatever telescope at that observatory. Some telescopes have bigger fields of view, some have smaller, and you can position it. And you want to position it around the terminator, keeping in mind that it may be a day or two before it dispatches, so the terminator is going to move to the left. So maybe I'll do something like this. Maybe I'll try to get that crater in, but I'll anticipate that it'll be lit a little bit more here. And so I've set offsets. It's a graphical way to do some special settings. And right now the moon is just barely visible, but within a day or two, it'll only get better. For filters, you want the low through. The moon is super bright, so any of the filters that block most of the light, narrowband or U is fine. And then you pick that one telescope that you selected, prompt Meckering. Save and continue. And I think for this one, it doesn't matter if you use the generic or not. We tell you just 0.1 second exposure. It's here in the lab, low through 0.01. Save and continue. Submit. And it'll work its way back to the checkout screen. That's it. This is beyond the labs. There's a little video here on how to make a color image. And I would wait until they get their deep sky objects back, so like in week 2, and see which one was their favorite, and they can go in and submit a red, green, blue. We tell them whatever exposure time you use for your deep sky object in the high through filter, multiply by 4/3 for R, 6/3, so 2 for V, and 8/3 for B, and submit again. And then in a week or two, when you have some time, you can work through this video with them and make a color picture. They like that kind of stuff. And here, I'll just show you an example of the moon. And that'll be it. I think I have one on the next page. Yeah, this is the one I just submitted. There's one I submitted an hour ago or so. And moon. Maybe one of these. And here, this is for the MWU curriculum where we mosaic the whole thing in 3 bands and make a color picture. But, this is kind of typical quality they'll get. So that should be exciting for them as well. So next week, we'll learn what to do with all these images. If you have the time, I encourage you to go through the lab and actually submit these observations. And then you can use your own data next week when we go through stuff. Okay, sorry for going over, but I'll stop there. And I'll stick around for questions. But otherwise, see you next week.
Thank you.
Thank
Thanks a
you,
lot.
Dan.
Does the WebAssign interface work well on an iPad?
On an iPad, I think so. I think the bigger question is, does like Afterglow work well on an iPad?
Okay.
WebAssign is just, well, all this is in the browser, of course,
Or
but Afterglow, is using the browser in a very different way. It's using it almost
Yes.
looks like desktop software. WebAssign should be fine. And I think Afterglow also works on iPads. Yeah.
okay. We until this year we provided iPads to students for several years. We've kind of stopped doing that, but I'm still going to have a lot of students where that's kind of their primary device. I intend to have computers available, like real computers as well, but a lot of them are probably still hardwired to use the iPad for anything, which they
Should be
are
fine. If it was a problem, I would think that I would know it, because I'm sure with
probably.
3,500 students a year, this would have come to my attention by now.
Yeah, I would think so. Okay, great. Thank you.
Excuse me, Dan, I have a question about the access to that one that is in my account is pending. You're gonna inform me, is that gonna be, because we're gonna do this activity, probably I should wait till that action be completed, right?
Yeah, I will email them like right now when we're done about these remaining counts, asking them to move them along. And next week I'm just going to go through the activities. There won't be time to follow along and do it, but you'll be able to do it in your own time. But yeah,
Thank you.
you're gonna want to be able to see the lab before doing it.
Okay, thank you very much. I appreciate it. That's great information. I
Yeah,
have to catch up by next week. Thanks a lot.
sure, my pleasure.
Have a great day.
You too.
Hi, Dan. Yeah, same question with the account stuff. I just I guess my account's pending. I guess he has to be verified by my school or something like that. So
Yeah, though if I send an email saying please rush this, I think they count that as verification. And so I'm gonna send that email right now.
alrighty. All right. Thanks, Dan. See you
Sure.
next week.
See ya.